Hi everyone. Today we are going to discuss about the Fourier series. So before we start the session, we are going to understand how to create the square wave by adding a couple of sine wave. So we are going to use the MATLAB to plot the graph. So first, what we have to do is we have to define our time. So here the time is defined between 0 to 2 pi, and we will define our first harmonic or the fundamental signal, which is y is equal to 3 sine t. Now we can go on defining our next harmonic, which is y1 is equal to sine 3t, and we have one more signal, which is y2 equal to 0.8 sine 5t, and the last one we have y3 is equal to 0.4 sine 7t. Now we will plot each sine wave and we will see what the graph is going to look like by using the command plot t comma y, t comma y1, t comma y2, and t comma y3. Now you can see we have plotted fundamental frequency and its harmonics. Now we add the signal together and we will plot individual frequencies and the summation of all the frequencies. By looking at this graph, the green color signal, which is the summation of all the sine frequencies, it takes the similar form of the square wave, but not exactly. Why is that? Because we add only 3 to 4 signals here. So when you increase the number of frequencies, you can get square wave with a flat response. Now we are going to discuss about how this can be related to a Fourier series. A square wave can be created by adding a couple of sine waves together. When you increase the number of frequency, you will be getting exactly the original signal. Now we are going to send this square wave through a bandpass filter. What is a bandpass filter? Which allows wanted frequencies and cut off or chopped off unwanted frequencies. The wanted frequencies will be in the spectrum of omega 1 to omega 2. Within the bandwidth of omega 2 minus omega 1, all the frequencies will be allowed and all the other frequencies will be cut off. So when this square wave is subject to this particular bandpass filter, let's assume our omega 1 is equal to 2 and the omega 2 is equal to 6. And we know the fundamental frequencies used to create the square wave, which is 3 sine t, sine 3t, and sine 5t, and sine 7t. So by looking at that, we can tell the output will contain only 3 and 5. Because only those two frequencies are aligned with this particular spectrum. And 1 and 7 will not be allowed by this bandpass filter because which is not in the spectrum. If we know what are the frequencies available in a complex signal, then we can easily understand, okay, if that particular signal is subject to a bandpass filter or any sort of a filter, what will be the response? Because sometimes each frequency will carry certain information. So you have to make sure the generated information is passed through the filter. So now the question is, how to decompose a complex signal into fundamentals of sine waves, where the Fourier series helps to do that. The Fourier series states that xt can be expressed by the trigonometric Fourier series. Xt is equal to a0 plus algebraic summation of an cos n omega 0 t plus bn sin n omega 0 t. So we can conclude any complex periodic waveform can be expressed as a sine and cosine waveform by using the Fourier series. The term A0 is called the DC component of the series. It represents the average value of xt over a period. The term an cos n omega 0 t and bn sin n omega 0 t is called the nth harmonic of the series. Now, to conclude this session, you can figure it out where the Fourier series is used. If you want to decompose a complex signal into a couple of sine wave or cosine wave, you can use the Fourier series. Why you have to do it? Because sometimes you want to analyze which frequencies are carrying the information, whether those frequencies are passed through a bandpass filter or any form of a filter. This is one particular example in the base of signal processing, but there are many applications where you can use the Fourier series to identify the signal and the signal pattern. With that, we are concluding today's session, and we will discuss about Fourier transform in the next session.